Okay, so the next one says, examine the geometric relationship in each of the diagrams below. For each one, write and solve an equation to find the value of the variables. Name any geometric property or conjecture that you use. So here we're using mid-segment, and that is on the back bottom right of your toolkit. And we know 2 of these will fit into this to be equal to that. So 2 times 3m plus 5 equals 5m plus 11, and you just want to make sure what you're looking for. We're looking for m here, so we would just stop when we find m, but in this one we're looking for PQ, so we would go one more step. So distribute 6m plus 10 equals 5m plus 11. We're going to take away 5m from both sides. There's other ways to go about this and still get to the same result, so if you did this differently, that's okay. M plus 10, because 6m minus 5m is m, and then take away 10 from both sides. I get m equals 1. So the next one is the same situation, except we are finding the length of PQ. So we're going to do this over. 2 of these equal this, so 2 times x plus 9 equals 4x minus 27. So distribute 2x plus 18 equals 4x minus 27. And then I'm just going to take away 2x from both sides to make sure I'm working with positives, but again, you can work with negatives if you want. 18 equals 2x minus 27. I'm going to move this to the other side to get 2x alone, so plus 27 on both sides. So 2x, I'm running out of room. 2x equals 45, and then divide both sides by 2 to get the x alone. So x equals 22.5, and then I'm going to take that and plug it in to find PQ. So PQ is x plus 9, so PQ should equal 22.5 plus 9. So 22.5 plus 9 is going to be 31.5. So PQ equals 31.5 units. There's no units on there, so it would just be units. And then the next one, it says PQRS as a rhombus, so that means all these sides are equal with a perimeter of 28. So if I say 28 divided by 4, that's all those sides, because they're going to be equal, so that's going to give us 7. So these are all 7. And then it says PR, all of this is 8, but we know that the diagonals bisect, so we're going to get 4 and 4. And when it says find PQ, or sorry, QT, QT, which is labeled as B here, and also QT and PT make a 90 degree. So I actually, let me get a highlighter. I have like a right triangle right here. Oops. That I can work with. So this little right triangle here, I'm going to rotate it. This is 90, B, 7, and 4, and now I just have a Pythagorean theorem situation. So 4 squared plus B squared equals 7 squared. So 4 squared is 16 plus B squared equals 7 squared is 49. And then I'm going to take away 16 from both sides to get B squared alone. So I get B squared equals 49 minus 16 is 33. And then I'm going to take the square root of both sides. So B equals 5.745. So then the next one, this is a kite, and we know these opposite angles are equal to each other by one of the properties on our toolkit. So I'm going to set these equal and just solve them. So since we have x here and 2x, I'm just going to take away x from both sides, but you can switch it, that's fine. 2x minus x is just x, minus 5 equals 13. 1 second.
Rockin' Robins. How many do you want?
Okay, sorry about that. So I'm going to add 5 to both sides. X equals 18. All right, so then the last one, it says, given the information in the diagram below, prove that Wx is congruent to Yz. That's already on there. And it says using either a flowchart. It was supposed to be using a flowchart. So, sorry. Here, get rid of that. So, in my class, we do given at the top, prove at the bottom, box in the middle. So let's do that. We've got 2 givens. We know that the box in the middle has to be congruent sides and angles, and then congruent triangles. So with that being said, this is one of the givens that goes in here, and this given goes up here. So we're gonna write that first. Didn't really look at the picture very much yet, but just copying that stuff down. You can put this angle Z is congruent to angle X in any of those 3 and write given. So I took care of the given. The proof goes at the bottom. I don't know why it's true, or I wouldn't be doing a proof. So that's done. And then box around this. If you're not my student, if you're not Ms. Robinson's student, you probably don't do that. But it is still a good option to think through. So we know this has to be congruent triangles that lead to the ending. So looking now at our picture, we can utilize what we know. So I want the triangles to be congruent in the picture, so I can utilize the parallel lines. So I'm going to use that Z there. And I want these angles to be equal because those are alternate interiors. So I'm going to say angle ZWY is congruent to XYW. And that is if parallel, then alternate interior angles are congruent. And that comes from the parallel. I've seen in my classes a lot of people are doing given to given, and that's not good. Given does not lead to given. They are separate. So then now the last piece I need to talk about is the sides in the middle that are the same. So WY is congruent to a YW. They are switched in this one, and that's reflexive. And just a heads up, if you're worried about these, you will have a bank on this one on the test. We just wanted to have you practice without it. And then these 3 things lead to the triangles being congruent. Don't forget your arrows. And then I'm just going to steal the order that is already up here so I don't have to do it again. Rewrite it. And then the reason for that, if you've drawn in your picture, you'll know pretty quickly, is angle, angle side, congruence. And then the last step is to show that the pieces of these triangles are congruent, and that would be CPCTC. Corresponding parts of congruent triangles are congruent.